Please refer to page 324 of your textbook for this lesson. In this lesson, we have a manufacturer that produces model cars. I'm setting up GeoGebra now under the options and settings to make sure only the positive axes for the X direction and for the Y direction are set. Select Graphics from the drop-down menu, then click on the tab Axis. Click on the positive direction only. Then you're going to repeat this for the Y-axis. Then go to the Grid tab and Show Grid. I'm going to let X represent the racing cars. One of the constraints is that the number of racing cars has to be less than or equal to 40. I've graphed it here, but it's now off the screen. I'm going to have to zoom out so that I can see the result. Now I'm going to let Y equal the number of SUVs. Its constraint is that it has to be less than or equal to 60. I've graphed it here, and I've had to zoom out again to show the results of the two areas. I've also used the Move tool, and I've grabbed the X-axis and stretched it out so that I can make full use of the screen. The double shaded area represents all possible combinations of racing cars and SUVs that meet the condition that the racing cars must be less than or equal to 40 and the SUVs must be less than or equal to 60. Now I'm going to add the further constraint where the total of the cars, the racing cars plus the SUVs, must be less than or equal to 70. Or in this case, X plus Y is less than or equal to 70. Here then is the result of the three constraints graphed together on the same grid, and we have different areas. We've got the area where all three inequalities have a common solution set. That means all three inequalities are true in this triple shaded area. The mouse is over a region where there are more than 70 cars built, so that's not allowed. And furthermore, the solution shaded shows that there are too many racing cars being built in this region. The only inequality that is satisfied is that there are fewer than 60 SUVs built. Before we start dealing with the cost of building the cars, let's recap. X represents the racing cars and Y the sports utility vehicles. There were three constraints. The racing cars had to be less than 40. The SUVs had to be less than 60, and the total had to be less than 70. One of the limitations of GeoGebra right now is kind of misleading. It indicates that all values are allowed in the shaded region, but that's not the case. We use only whole numbers to count the number of cars. The polygon that represents a solution set is called the feasible region, and that feasible region contains some pretty important points. Now we're going to deal with the cost of building these model cars. The cost to build a racing car is $8, and while the cost to build an SUV is $12. Start the spreadsheet by going to the View menu and selecting Spreadsheet. My spreadsheet here has been modified and adjusted to include the titles, point, number of racing cars, number of SUVs, the cost to make the racing cars, the cost to make the SUVs, and the total cost. The questions that we've been asked is what's the minimum cost and what's the maximum cost. In working with linear inequalities such as this, in this way, the key points are at the corners, if you can call them corners, of the feasible region or the polygon that we've drawn. So I'm starting to type the points now, 0, 0 being the first one. As I type the points in cells A2 through to A6, those points represent the 5 points of the polygon, and GeoGebra was nicely labeling them for us. As you can see, as they get typed in, my points A2, A3, A4, A5, and lastly A6 gets typed in. I'm going to enter the data and the formulas to calculate the total cost of the cars for the points that we're talking about. So right now I've just finished entering the points. 0, 0, meaning 0 racing cars and 0 SUVs. The cost of making one racing car is 8 times B2, which is where the racing car is. The cost of the SUVs is $12 times the number in C2. The total, of course, is just adding D2 plus E2. I'm going to repeat it for the next point, and the next point has 0 racing cars and 60 SUVs. I'm going to make a shortcut and copy down all the formulas. And now when I enter the other points, the coordinates of the other points, 10 and 60 and 40 and 30 and 40 and 0, the spreadsheet will recalculate the values. By quickly scanning the data, we can see that the zero cost, or the minimum cost, occurs when we make no cars, that is 0.00, and the maximum occurs when we build 10 racing cars and 60 SUVs. If there were a huge amount of data, we would use the min and max function, which I'm showing you right here, and we'll discuss it in class the next day. So we're done the problem now. We've got the objective function, which is the total cost of the cars, 8x plus 12y, and we found the minimum at 0, 0. That means 0 racing cars and 0 SUVs. And then the maximum cost occurs when we build 10 racing cars and 60 SUVs. So here's the data again. Make sure you watch this video again, especially when we work on more optimization problems, and that'll be the end of the unit.